Hi, these are the answers to the homework of lesson 16 Doppler effect. Question 1 gives us a particular star that is moving towards Earth. So in part I, state the direction of the observed frequency shift. Since we know it's moving towards Earth, this is a blue shift. Part II asks us to determine the speed at which x is moving towards Earth. We have to use this equation for electromagnetic waves. We know the change in frequency, we know the emitted frequency, we know the speed of light. So substitution gives 8.5 times 10 to the power of 3 meters per second. This is assuming that the speed is much less than the speed of light. Doppler effect is the change in observed frequency due to the relative motion between the source and the observer. The question gives a child on a carousel that is moving with a speed of 6.5 meters per second along a horizontal circular path. A stationary observer is at a large distance observing the sound made by the whistle. We know the question gives us a case of moving source with sound wave, and we're asked to find the minimum observed frequency. We know the speed of the wave and we know the frequency emitted. We also know the speed of the source. Substitution into the moving source formula with the positive sign, because we're looking for the minimum value of this observed frequency, we get 830 Hertz. As time passes, the frequency will increase to a maximum value while the whistle is moving closer. And as the circular motion continues, the frequency observed will go back to the minimum value. So this is going to be repeating in a cycle. In question 3, we need to pick option D because we know there will be a larger frequency heard when approaching and a smaller frequency observed when moving away. So we need to say that the frequency varies during the journey. In question 4, we have a radar gun case which works with an electromagnetic wave, and we know the Doppler effect takes place twice, and the observed frequency will be less than f because the source is moving away, and that is given in option C. Twice this ratio subtracted from the frequency, that is C. Question number 5 is D because we know the observer would measure the same speed but a larger wavelength, so the option D is the reasonable choice among these options. Question 6 is a case of moving source and the stationary observer. We know that the observer would hear a larger frequency when approaching and smaller when moving away. That gives us a choice between option A and C. We know the emitted frequency is not 0, so it can't be A. Answer is C.